Hi everyone. Today we're going to be solving Pearson EDEXCEL GCSE Chemistry Foundation Tier June 2020 paper. When solid sodium chloride is mixed with water, sodium chloride solution forms. What name is given to the process of mixing a solid with water to form a solution? Now, mixing a solid that is going to dissolve in water to form a solution should be dissolving. So C is the correct answer. Now let's see the other options. Crystallizing is the process of obtaining a solid from an solution. Diluting is the process of making a solution less concentrated. Melting is the process of turning a solid into liquid using high temperature. Sodium reacts with hydrochloric acid to form sodium chloride and hydrogen. Write the word equation for this reaction. So to write a word equation, always focus in the reactants. Those that are reacting must be in the left hand side. And after the word formation means the product that is forming will be on the right hand side. Sodium plus hydrochloric acid produces sodium chloride plus hydrogen. The hazard symbol shown in figure 1 is used on containers of sodium. What is the meaning of this hazard symbol? The symbol represents something is burning, so flammable. Hydrogen has one electron in its electron shell. Figure 2 shows the incomplete dot and cross diagram of a hydrogen molecule. Complete figure 2 to show the electrons in the covalent bond between the two atoms of hydrogen. Now, since hydrogen has only one electron in its outer shell, so both of the electrons will be needed in the sharing portion. So one of the hydrogen will be represented with a dot, the other one will be represented with a cross. The pH of sodium chloride solution was measured. State what could be used to measure the pH of a solution. To measure the pH of a solution, pH meter is the best solution. However, universal indicator can also show pH. Sodium chloride solution is neutral. Give the pH of this solution. Any solution that will be neutral will have a pH of 7. Chlorine has an atomic number of 17. Figure 3 shows the arrangement of electrons in an atom of chlorine. From the diagram here, we can see the electronic configuration is 2, 8, 7. What is the electronic configuration of this atom? So the answer will be C. Electronic configuration has to represent the electrons in every shell. For that reason, A and B are not correct. D is incorrect due to opposite order. The first shell is represented as shell number 1, followed by shell number 2 and 3. Explain using figure 3 why chlorine belongs to group 7 of the periodic table. In the electronic configuration, we can see chlorine has 7 electrons in its outer shell. So the answer will be chlorine contains 7 electrons in its outer shell. Another way of writing the same answer should be the number of electrons in the outer shell is the same as the group number. The nucleus of an atom is made up of protons and neutrons. Atoms of chlorine contain 17 protons. Figure 4 shows some information about a proton and a neutron and an electron. Proton having the relative mass of 1 and a relative charge of +1. Neutron having the relative mass of 1 and a relative charge of 0. And electron, the relative mass is very small and the relative charge is -1. Explain using the information in figure 3 and figure 4 why atoms of chlorine have no overall charge. In figure 3, it is represented that the chlorine consists of 17 electrons. In figure 4, it states that protons are positively charged and electrons are negatively charged, and an atom of chlorine has 17 protons. So the answer can be written, there are same number of electrons and protons in the chlorine atom. So the charges cancel out one another and makes it neutral. Atoms of chlorine 37 has a mass number of 37. Calculate the number of neutrons in the atoms of chlorine 37. Mass number minus the number of proton is equals to the number of neutron. So it consists of 20 neutrons. There are two isotopes of chlorine, chlorine 35 and chlorine 37. So chlorine 37, we have already found out it consists of 20 neutrons, whereas chlorine 35 must consist of 18 neutrons. So we can see they have a different number of neutron or different mass number as a result. Explain the meaning of the term isotopes. The answer can be written, atoms of the same element or atoms having the same atomic number but different number of neutrons, or different mass number. Atoms with the same number of protons but having different number of neutrons, or we can write atoms with the same atomic number but have different mass number. This is the meaning of the term isotopes. In industry, ammonia is manufactured by reacting nitrogen with hydrogen. Give the name of the industrial process to manufacture ammonia. The manufacture of ammonia is known as the Haber process, named after the person Haber. Write the word equation for this reaction, including the correct symbols to show that the reaction is reversible. Now, in order to write a word equation, always look into your reaction. Who are the reactants? So the reactants are nitrogen and hydrogen. Now, nitrogen and hydrogen are combined together to produce ammonia, which is the product. To write down the equation, we will write nitrogen plus hydrogen, give an arrow, and then write ammonia as the product. Now, this reaction is a reversible reaction, so we will change the arrow to reversible sign. The formula of ammonia is NH3. State what the formula of ammonia shows about the number of nitrogen atoms and the number of hydrogen atoms combined in a molecule of ammonia. With the formula NH3, it explains that there is one nitrogen atom and 3 hydrogen atoms in a molecule of ammonia. Most of the ammonia manufactured in industry is used to produce fertilizers. A fertilizer is made by reacting ammonia with nitric acid. What is the name of this fertilizer? Since we are reacting ammonia with nitric acid and a salt of nitric acid is nitrate, a salt of ammonia is called ammonium. So the name will be ammonium nitrate. The reason is ammonia, after the reaction with nitric acid, turns into the ion ammonium and the nitric acid turns into the ion nitrate. Explain the importance of fertilizer in farming. For this particular question, you can give a generalized answer for every time. The answer can be written as follows. Crop requires fertilizer to grow. Fertilizer consists of nitrogen, phosphorus, and potassium compounds. These compounds promote plant growth, thus increases the yield of crop, and this means a greater profit. Any two of the points will give you your full marks. So do not be tempted to write more than 2 points. Just choose any of the 2 points which you like and repeat it whenever you have a question that says importance of fertilizers in farming. In the 19th century, Mendeleev arranged the elements known at the time to form his periodic table. Mendeleev's periodic table is different from the modern periodic table. State one difference between Mendeleev's periodic table and the modern periodic table. So the answer can be written as follows. Mendeleev's periodic table is arranged by order of relative atomic mass, and there were fewer elements. Also, noble gases were not present in Mendeleev's periodic table. Aluminium oxide reacts with hydrochloric acid to form a salt and water. State the name of the salt form. So the salt form will be starting with the name aluminium and ending with the acid, which is the hydrochloric acid, so chloride. In this reaction, aluminium oxide is a base. So all metal oxides are bases. State the type of reaction that takes place when acid reacts with a base. The reaction of an acid with a base is referred to as neutralization reaction. Gallium is the same group of the modern periodic table as aluminium. So gallium is also in group 3. All group 3 elements has 3 electrons in the outer shell. So gallium also has 3 electrons in outer shell, same as aluminium. The formula of aluminium oxide is Al2O3. Predict the formula of gallium oxide. So since aluminium oxide is Al2O3, gallium oxide will be Ga2O3. Now guys, you can think of this in the other manner just by using math as well. So Ga and O. Oxygen has the oxidation state of -2 and gallium has the oxidation state of +3. So when we exchange these numbers, we get Ga2O, Ga2O3. Gallium oxide has a very high melting point. Gallium oxide does not conduct electricity when solid, but does conduct electricity when molten. What type of substance is gallium oxide? So, does not conduct electricity when solid means contains ions. Since the ions, when they are molten, they are mobile. Mobile ions can conduct electricity. So the answer will be ionic. Simple molecular substances do not conduct electricity. Metals conduct electricity when they are solid due to free electrons. And giant covalent also do not conduct electricity except graphite. Figure 5 shows the changes of state for gallium and the arrangement of particles in liquid gallium. So the first diagram represents solid gallium. The second one represents liquid gallium. As you can see, liquid particles are not neatly arranged. They rather have a little bit more space and irregularly arranged. And then after evaporation, gaseous gallium will be far apart. Complete the boxes for solid gallium and gaseous gallium by drawing the arrangement of particles in each of these physical states. So for the gaseous gallium, we have to draw them far apart and randomly. We will not be seeing as many molecules as we see in the liquid gallium in the same space. In the solid gallium, we're going to have the gallium in regular arrangement. Since metals have regular arrangement and the elements must be touching each other as well. So regular arrangement and touching. For solid, regular arrangement and touching. For gases, widely spaced and fewer molecules shown. Give the name of the change of state labeled Y in figure 5. So opposite of evaporation will be condensation. Condensation is the process when gases, they condense to form a liquid. Gallium metal is a conductor of electricity. Explain how metals conduct electricity. So the answer is very simple. It comes with the definition of metallic bonding. So metals have delocalized electrons, and these delocalized electrons can move throughout the structure and they can also carry charge. So the answer can be written, metals have delocalized electrons which can move throughout the structure carrying charge. The main marking points are coming from the point delocalized electrons, and the delocalized electrons can move. Transition metals have many uses. The pie chart of figure 6 shows the uses of transition metal. 7% is used for transportation, 3% is used for coin making, 65% of the transition elements are used for electrical equipment making, and the remainder percentage is for construction. Calculate the percentage of this transition metal used in construction. So this will be very simple because the whole pie is equals to 100%. So minus 65 plus inside bracket 7 plus 3 will give us the percentage used for construction. This leaves us 25% for construction. Figure 7 shows 5 statements about iron. Put ticks in the boxes in figure 7 to show statements are true and which statements are false. The first one has been done for you. Iron is a poor conductor of heat. So since iron is a metal and we know it's a good conductor of heat. Next one, iron can act as a catalyst. Iron is a transition element, so it can act as a catalyst. So the statement is true. Iron forms compounds that are colored. Iron belong in the transition group of element, and transition group of element forms colored compounds. So this is true as well. Iron has a low density. This is false because transition group of element have higher density. Iron has very high melting point. Transition group of elements have very high melting point. So this is true as well. Most iron produced is converted into alloys of iron. State why alloys have much more uses than pure metals. Alloys are generally stronger than pure metal, and pure metals are weaker. Alloys are also corrosion resistant, whereas pure metal are not as much corrosion resistant as alloys. So 2 sets of answer can be written. Choose any one and write in your exam. An alloy of iron contains 0.4% of molybdenum. Calculate the mass of molybdenum contained in a 30-gram sample of this alloy of iron. So since it contains 0.4% and we have to find out in 30-gram sample, so 30 gram multiplied by 0.4% will give us the mass of the molybdenum. This gives us 0.12 gram. Many transition metals are used to make the reactants in chemical cells. Figure 8 shows a graph of the voltage produced by a chemical cells as it is used in a torch for many hours. We can see the voltage and time in hours, and the voltage is decreasing. Suggest an explanation for the shape of the graph. A chemical cell is similar to a battery. It uses up chemical as a reactant. Over the course of time, the reactant runs out. Also, before the reactant runs out completely, concentration decreases. So the answer can be written in this way. From the graph, we can see the voltage is decreasing. So we can say the voltage decreases as time passes because the reactant are used up or the transition metal is used up. Some metals are found in the Earth's crust as uncombined elements. Reactive metals are found in ores. In ores, metals are combined with other elements. Which of these metal is found as the uncombined element in the Earth's crust? To get an uncombined element, we must have that element very unreactive. So, from the diagram, we can see aluminium, potassium, zinc, they are very reactive because they are very high in the reactivity series. So gold is the most unreactive of all the metals here. So gold is the correct answer. Give two advantages of recycling metals rather than extracting metals from their ore. So the answer asks for simple two advantages for recycling metal instead of extracting those metals from their ores. One of the biggest savings that we have when recycling metals is that it preserves the ore that we collect the metal from. The second one is that it requires reduced amount of energy to extract the metal by recycling. One alternative answer that we can write is that it preserves resources or landscape. An ore of iron is mostly iron oxide Fe2O3. Iron can be extracted from its iron oxide by heating it with carbon. Balance this equation for the reaction that takes place. So when iron oxide is reacted with carbon, it produces carbon dioxide. To balance the left-hand side with the right-hand side, let's look into the number of iron. There are 4 irons in the left-hand side, so 4 irons must be on the right-hand side. Now in terms of oxygen, there are 2 times 3, 6 oxygen present. So 6 oxygen will produce 3 carbon dioxide because 3 times 2, 6 oxygen. So 3 carbon will be needed to extract. Most copper ores are described as a low grade. This means that the percentage of copper in the ore is very small. 5,000 kgs of one copper ore was found to contain 42.5 kilograms of copper. Calculate the percentage of copper in this ore. To calculate percentage copper in the ore, we will put the amount of copper that we get in the top and the amount of materials that we have to utilize to get the copper at the bottom. Then we will multiply it by 100 to get the percentage. This gives us 0.85 or 0.85%. In one stage of the extraction of lead from its ore, lead oxide is heated strongly with carbon. So metal oxides are generally heated with carbon when the metal oxide is less reactive than carbon. So this metal is below carbon in the reactivity series. And in these cases, we can extract it by using carbon only, which is a very cheap method of extraction. Explain using this equation which substance has been oxidized in this reaction. In terms of oxidation, it means gain of oxygen. So carbon, we can see, has oxygen on the other side of the equation. We will say carbons gained oxygen to form carbon dioxide. This will give us 2 marks. A titanium ore was analyzed and found to contain 12 grams of titanium atoms combined with 8 grams of oxygen atoms. Calculate the empirical formula of this titanium compound. The atomic masses of titanium oxygen are provided. We must show our working how we came with the conclusion. So, when the compound that we can learn about is the titanium atoms combined with oxygen atom, meaning it is a titanium oxide. So, we will put titanium and oxygen, then we will write down the amount in mass that we reacted with. Then we will divide those masses with their relative atomic masses. After the division, the answer for titanium is 0.25 and the answer for oxygen is 0.5. Now, we will do a simplest ratio. In simplest ratio, we will use the smaller number of both of the number and we will divide with the smallest number of both of the number. Then this will give us whole number ratios in which they are reacting. So we can see 1 titanium is reacting with 2 oxygen. So the empirical formula now stands Ti for 1 titanium and O2 for 2 oxygen. Iron rusts when it is left in certain condition. Figure 9 shows the apparatus used to investigate the rusting of some iron nails. we can see air and water sealed in A, tube A. Iron nail is exposed in air and water both. Iron nail in tube B is exposed to a drying agent which is taking away the moisture from the air, and the tube is sealed. Tube is sealed in the first case as well. In the last one, in C, we can see the iron nail is dipped in boiled water. So boiled water do not have any dissolved oxygen, and there is an oil layer to prevent oxygen entering, and also sealed. In the case for drying agent, moisture is removed, so water is removed by the drying agent. Even the air is present, oxygen is present. In order for rusting to occur, both air basically, which means oxygen, and water needs to be present at the same time in order for rusting to occur. And the question says, explain why the iron nail in tube A would rust, but the iron nails in tube B and C would not rust. So, as said earlier, both air or / oxygen and water is needed for rusting. Tube A consists of oxygen and water present, whereas in tube B, only oxygen is present but no water present. In tube C, only water is present with the nail but no oxygen present. Magnesium is more reactive than iron. Figure 10 shows an iron nail with a strip of magnesium wrapped around it, placed in some water. The tube was left for a few days. Strip of magnesium wrapped around an iron nail. Now, from the diagram and magnesium nature, magnesium is more reactive. So it will react before the iron. Magnesium is more reactive than iron, so it will react before the iron. The question says, state what would happen to the iron nail. Obviously, the iron nail will not rust. When iron rusts, a brown solid forms on the surface of the iron. What happens to the iron as the rust forms? So basically, iron gets oxidized, and also at the same time, alright, so basically we will say because it gains oxygen, iron gets oxidized when it rusts. Hydrated is gaining water, and neutralization is the reaction between a acid plus a base, whereas the reduction is loss of oxygen. That's why C, iron is oxidized, is the best possible answer from the options. Give one reason why metals are electroplated. Electroplating can give many advantages, and one of the advantages is improvement of appearance, and the other one is we can coat a more reactive metal with a less reactive metal so that it is more corrosion resistant. The pure metals aluminium, copper and gold, and the alloys brass and magnesium are used to make many useful articles. The way in which these metals and alloys are used is related to their properties, such as their density, electrical conductivity, resistance to corrosion and their strength. State some uses of aluminium, copper, gold, brass and magnesium. Explain how each of the use is related to their properties. So we are asked to write for aluminium, copper, gold, brass and magnesium. Also, along with it, we have to explain why each of them are used in related to their properties. Aluminium is used in cooking foil because it is malleable and has a low toxicity and low reactivity, whereas copper is used as water pipes because of its low reactivity but does not corrode. Gold is used in electronics because it does not corrode, and also it is a very good electrical conductor. Brass is used for pins in electrical plugs because it is strong and hard wearing. Magnesium is used for making aircraft parts due to its low density. Guys, note that the above answer can score a level 1 or level 2 response if written in whole. However, to get a level 3 response for the same answer, we can write the answer in a different manner. So let's see how to write the answer in a level 3 response. So at first we will start with aluminium. Aluminium is used in cooking foil due to its malleability and low toxicity. Aluminium is also a very good electrical conductor when pure and has a low density, which makes it ideal for overhead cables. Magnesium, an alloy of aluminium, has low density and very strong, so can be used for making aircraft body parts. Copper, on the other hand, is used in electrical wiring because it's a good conductor of electricity, so current can pass through it easily. Copper is also used in making AC condenser tubing due to its high thermal conductivity and unreactivity when exposed to elements. Gold is used in jewelry because it is unreactive, so it does not cause irritation to the wearer. Whereas brass, which is an alloy of copper and zinc, it is used for making electrical plugs and pins because it is strong, so it will not break or bend easily. Both copper and gold are used in electronics extensively due to their good electrical conductivity and unreactivity. Figure 11 shows the apparatus that can be used to electrolyze sodium sulfate solution using inert electrodes. So sodium sulfate solution is used as the electrolyte. Now, the whole apparatus is connected to a positive electrode and negative electrode with a 6-volt DC supply, and we can see a gas X and hydrogen gas is being collected. Hydrogen gas is produced at the negative electrode during electrolysis. Describe the test to show the gas is hydrogen. Hydrogen has a classical test, which is if we apply a lighted splint, it creates a squeaky pop. What is the name of the gas that forms at the positive electrode? Now, the names of the gas formed at the positive electrode can be determined in this following way. Because the solution is sodium sulfate aqueous, so it consists of sodium ions, sulfate ions, and also, since it is an aqueous solution, consists of hydroxide ions and hydrogen ions. Now, hydrogen ions are released at the negative electrode. It is released in the form of hydrogen. So hydroxide will be electrolyzed in the positive electrode, which will be released as oxygen. Sulfate cannot be released from a aqueous solution. So the gas is oxygen. The other answers are not obviously correct because the solution does not contain any nitrogen, and sulfate do not get released from aqueous solution. So we'll say sulfate is not electrolyzed in aqueous solution. State what is meant by the term electrolysis. So this is purely asking us the definition of electrolysis. Now, electrolysis, the word electro refers to electricity and lysis refers to the breakdown using electricity. So electrolysis, we can give the definition as follows. It is the breakdown of electrolytes using electricity. The sodium sulfate solution was made by dissolving 28.4 grams of sodium sulfate in water to make 250 cm cube of solution. Calculate the concentration of this solution in gram per dm cube. Give your answer to 3 significant figures. 1 dm cube refers to 1000 cm cube. Since the solution is made of 250 cm cube, so to get the 250 cm cube to 1 dm cube, we'll have to multiply it by 4. So 28.4 gram was used in 250 cm cube. To get the 250 cm cube into 1000 cm cube, we will multiply the 250 with 4. This gives us 1000. So we will do the same for the 28.4 times 4, which gives us 114 grams. So the answer will be 114 grams in 1000 cm cube or 1 dm cube. The ions present in sodium sulfate are Na plus and SO4 2-. So sodium ion and sulfate ion. Write the formula for the sodium sulfate using this information. To write the formula, we will represent the two ions side by side with their charges at the bottom, and then we will exchange their charges number with them. This will give us Na2SO4. In figure 11, the gases given off at the electrodes are collected in test tubes. However, the actual volume of gases cannot be measured using these test tubes because test tubes don't have any graduation. So the volume cannot be measured. Suggest what apparatus could be used in place of test tubes in figure 11 to measure the volume of gases given off. So instead of test tube, it can be easily replaced by using measuring cylinder because measuring cylinder has graduation. State what could be added to the circuit to show a current is flowing during electrolysis. We can add a lamp, so when the lamp lights up, we will know that the electrolysis is going on. The word equation for the reaction between copper carbonate and dilute sulfuric acid is copper carbonate reacts with dilute sulfuric acid, which produces a copper sulfate solution along with carbon dioxide and water. So now they are asking us to complete the balance equation for this reaction. Let's go through this one by one. Sulfuric acid has a chemical formula of H2SO4 and copper sulfate has a chemical formula of CuSO4. So it will be H2SO4 and on the other side it will be CuSO4, copper 2 sulfate. Calculate the relative formula mass of copper carbonate. So to find relative mass, we'll write Mr CuCO3 and take individual values of those elements. Copper 63.5, carbon 12 and oxygen 16, but then there are 3 oxygens, so 16 times 3. When we add this up, this gives us a value of 123.5. What is the chemical test to show that the gas is carbon dioxide? Carbon dioxide can be easily detected by a lime water test. The positive result is indicated by cloudy solution. So bubble the gas through lime water. The lime water turns cloudy. Now let's see why the other options are not correct. Put damp litmus paper in the gas. Litmus turns red. This can only be performed on a gas that is alkaline or that is an alkaline gas. Turns red, so that is an acidic gas. We can do it only in acidic gas. Put a lighted splint into the gas. Splint is extinguished. Now this shows that the gas does not support combustion, but cannot say that the gas is carbon dioxide. Measure the pH of the gas. The pH is 4, which indicates an acidic gas. Figure 12 shows a conical flask containing dilute sulfuric acid. Copper carbonate is added to the acid in the flask. The copper carbonate is added one spatula measure at a time until the reaction has finished. So this is the spatula. We are adding the copper carbonate into the conical flask that contains the dilute sulfuric acid. State 2 observations that would show the reaction has finished. Because we are using a carbonate with an acid, an inevitable formation from this reaction would be a gas, which is carbon dioxide. It is known to form effervescence. If the acid is finished, then effervescence will stop. The other observation we can say is that the solid copper carbonate will remain at the bottom of the flask and will not dissolve or react. So no more bubbles / fizzing, and the solid copper carbonate remains at the bottom of the flask. Describe how you would obtain a solution of copper sulfate from the mixture and how you would obtain pure dry copper sulfate crystals from this solution. Your description should include the apparatus you would use, and you may wish to use a diagram in your answer. The mixture was filtered using a filter funnel and filter paper. The copper sulfate solution was collected in a conical flask. Once the solution is obtained, the solution was transferred into an evaporating basin. The evaporating basin was heated on a tripod over a Bunsen burner. Evaporate water until crystals start to appear around the edge. The evaporating basin is removed from the heat and it is allowed to cool and crystallize. The crystals are then separated using filter paper and also left in the filter paper to dry in a warm place. If we write the answer in this particular manner, definitely we are going to get a level 3 response and 6 marks. Potassium hydroxide reacts with hydrochloric acid to produce potassium chloride and water. Potassium hydroxide plus hydrochloric acid produces potassium chloride and water. The chemical formula for potassium hydroxide is KOH, hydrochloric acid is HCl, and the product potassium chloride is KCl followed by H2O, which is the water. A student carried out a titration to find the exact volume of dilute hydrochloric acid that reacted with 25 cm³ of potassium hydroxide solution. There were 5 steps in the titration. The steps shown are not in the correct order. First of all, in the step J it says, pour the potassium hydroxide solution into a conical flask and add a few drops of indicator in this solution. Step K, fill a burette with the dilute hydrochloric acid and record the initial reading from the burette. Step L, using a measuring cylinder to obtain 25 cm³ of potassium hydroxide solution. So just by looking into it, we can see step L has to be done before step J. Now, next point, take a final reading from the burette and calculate the volume of the dilute hydrochloric acid reacted. Run the hydrochloric acid from the burette into the conical flask until the indicator changes color. So as you can see, just by a simple reading, we can say step N is before step M. And also filling the burette should be before running it. So it will be before N. Now, the question is asking us to write the steps in the correct order. Some of the steps are completed for us. So, K is already done for us, which is filling the burette with dilute hydrochloric acid. So, after K, we can then definitely go for step L because it comes before J. And after that, we can place J and then N because N comes before M. Suggest an alternative piece of apparatus that could be used in step L to obtain exactly 25 cm cube of potassium hydroxide solution. Instead of using a 25 cm cube of measuring cylinder, measuring cylinders are quite inaccurate. To measure an exact volume which is needed for titration, we can use a pipette. A student was then asked to produce a pure sample of solid potassium chloride. After the final reading of the acid reacted in step M, the student added this volume of acid to a fresh 25 cm cube sample of potassium hydroxide solution. This mixture was then evaporated. So, the student repeated the same experiment in the second step, but this time the student has done it without the indicator because the indicator would act as impurity. Explain why this new mixture was evaporated rather than the original mixture from the titration to produce a pure sample of solid potassium chloride. So the solution from the titration contains an indicator, which is an impurity. So therefore, the second solution is used, which has no indicator. So it will not contaminate the salt that is produced. After evaporation, the mass of potassium chloride was determined. The theoretical yield for the experiment was 0.7 gram. However, the actual yield was 0.84 gram. This gave a percentage yield which is greater than 100%. Calculate the percentage yield of this experiment. So, percentage yield is equals to the mass of the obtained product divided by the theoretical mass of the product times 100. This gives us 120%. Suggest a reason why the actual yield was greater than the theoretical yield. An easy explanation could be water, presence of water of hydration, or we can just simply say the potassium chloride salt was still wet. The equation for the reaction between potassium hydroxide solution and dilute hydrochloric acid. Potassium hydroxide reacting with hydrochloric acid produces potassium chloride and water. Calculate the atom economy for the production of potassium chloride from potassium hydroxide and hydrochloric acid. The relative formula masses of these compounds are provided individually. So, in order to calculate atom economy, we will put the mass of the desired product on top and mass of all of the reactants at the bottom. So potassium hydroxide 56, hydrochloric acid 36.5 times 100. This gives us atom economy which comes out to be 80.540. Now rounded to 1 decimal place gives us a value of 80.5. So the atom economy is 80.5. Guys, that's the end of this particular video. Thank you for watching this particular video. Hope this helped you learn how to answer the question answers and write a very nice possible answer. If you have any questions, you can ask in the comments. And guys, question paper videos like this will be uploaded regularly. So let your friends know about it as well so that they can get benefit from it as well. Thank you guys for watching the video. See you in the next video, guys. Bye-bye.